Hey everyone, and welcome to the second video in this lesson. In this video, I'm going to show you guys more examples of using L'Hopital's rule. So let's go ahead and get started. All right, here we are in example A. We just want to find the following limits. Now in this problem, what we could remember, I told you guys back when we were studying limits that you didn't need to memorize this. But what we could remember is what is cosine of x minus 1 over x. Now let's say you don't remember that, right? And so we have the limit as x approaches 0 of cosine of x minus 1. And if I plug that in, I get 0. And in my denominator, the limit as x approaches 0 of x squared minus x, which also equals 0. So as I'm going through this, I can apply L'Hopital's rule. So let's go ahead and apply our rules of derivatives here and figure out what is L'Hopital's rule, or what are the derivatives of the numerator and the denominator to go ahead and do it. So that is going to be negative sine x over 2x minus 1. What I'm going to do is find the limit as x approaches 0 of this, and I'm going to get negative sine of 0 over 2 times 0 minus 1. Negative sine of 0, sine of 0 is 0, so I'm going to get 0 over negative 1, and so this value, this limit, comes out to be 0, and you'll see it if you were to graph it. Of course, you would get the same answer if you were to apply some of those rules that we learned back from limits, but again, let's say you don't remember that, we can still apply L'Hopital's rule. So this is the one you don't want to forget. All right, let's look at problem B, because this has some limits or some derivatives that we really haven't seen. We're going to study these later in the unit, but they're here in this section, and I wanted to kind of keep them here because they're pretty straightforward, and I want to make sure that we get introduced to this looking at these values immediately. So we had the limit of the numerator as x approaches 1 of natural log of x minus x plus 1. All right, so the natural log of 1 is 0. Minus 1 plus 1, we're getting 0. And in my denominator, the limit as x approaches 1 of e to the x minus ex. So e to the x is e minus e times 1, so minus e. So I'm getting 0 in my denominator. So we're going to apply L'Hopital's rule, the limit as x approaches 1, and we're going to take these derivatives. And I know you don't really know what these derivatives are, but anytime you see natural log of x, that's just 1 over x minus 1. And anytime you see e to the x, is just stays the exact same, e to the x. And like I said, we're going to just study these a little bit later. And then minus the derivative of ex, which is just minus e. All right, so let's go ahead. Let's see if what happens when I plug in 1. In my numerator, I can see that I'm getting 0. In my denominator, I'm also getting 0. So let's see what happens here. I'm going to write out that I am checking these limits. The limit as x approaches 1 of 1 over x minus 1, that equals 0. And the limit as x approaches 1 of e to the x minus e is also 0. Okay, so I'm going to scroll down, and I am going to apply L'Hopital's rule again. Just keep in mind when I apply L'Hopital's rule, when I'm taking this derivative, I'm just going to think about this as x to the negative 1 right here. Okay. All right, so let's find the limit. X approaches 1 of the derivative of the numerator, so that's going to be negative 1 over x squared minus 0 over just e to the x, because e is a constant. Okay, so let's see what happens when I plug in 1 now. I get negative 1 over e to the first. Okay, so I get negative 1 over e as my answer, right? Not something that we could easily figure out using algebra skills, but with what we know now, these derivatives, we are able to apply L'Hopital's rule and figure out these limits a lot easier. All right, let's go look at a couple more examples here. Example C, this one is going to infinity. And what I really want you guys to know is you should not be applying L'Hopital's rule in this case, because the degree of the numerator is the exact same as the degree of the denominator. But let's just take a look and see what happens. If I were to plug in infinity, my numerator, the limit as x approaches infinity of 1 minus 4x minus 5x squared, well, that is going to negative infinity because it's an even function and it opens downwards, so negative infinity. And the limit as x approaches infinity of 3x squared minus x minus 4, that equals positive infinity. So whenever you get these infinities over infinities, that is an indeterminate form. So we are going to take the derivative of the numerator and denominator. So the limit as x approaches infinity of negative 4 minus 10x over 6x minus 1. And again, I'm getting negative infinity over positive infinity. So let's write that out. The limit as x approaches infinity of negative 4 minus 10x, which is my numerator, equals negative infinity. infinity. In my denominator, the limit as x approaches infinity of 6x minus 1, that is going to positive infinity. All right, so I am going to apply L'Hopital's rule again, and I am going to take this derivative. So it's going to say the limit as x approaches infinity of negative 10 over 6. Well, that's an easy limit. That's just negative 5 over 3. So we can even take these limits all the way down to just their basic coefficient. And again, we didn't even need to do that in this case. I would be highly skeptical of a student who is going to apply L'Hopital's rule a couple times here and apply derivatives, because you could just look at the degree of the numerator and denominator and get negative 5 over 3 immediately. But let's just say on test day you forget that and you're just like, I know L'Hopital's rule. Well, here it is. You can still apply L'Hopital's rule. All right, moving over here to a question D, we can see what's happening. The limit of my numerator as x approaches infinity is going to be positive infinity. So 4x squared minus 5x plus 2 equals positive infinity. And the limit as x approaches infinity of my denominator, e to the 5x plus the natural log of x, is also going to be infinity. Okay, so we can apply our derivative rules. So the limit as x approaches infinity of 8x minus 5 in my numerator, and the derivative of my denominator. So e to the x is the exact same thing, but this is e to the 5x. So we are going to need to do a chain rule. So it's going to be 5e to the 5x plus the derivative of natural log of x is 1 over x. Again, you're going to see a couple of these in the practice problems, but we're going to go into depth with these in a later day. Okay, so let's look at what happens when I plug in infinity. Well, the limit as x approaches infinity of my numerator, 8x minus 5, well, that's going up to positive infinity. And let's check my denominator, limit as x approaches infinity of 5e to the 5x plus 1 over x. Well, that is also going up to positive infinity. So let's apply L'Hopital's rule one more time. The limit as x approaches infinity of 8 over 25e to the 5x minus 1 over x squared. Little bit of a power rule there, kind of done in my head. And now when I take this limit and I plug in infinity, my numerator is 8, but my denominator is going to infinity. So this entire limit is approaching 0. 8 over infinity is what we're getting, right? Because I get 8 and my denominator I'm getting infinity. So that's what's happening. That's why I'm thinking about this as 0. And again, you could get that potentially just from looking up here. I have a quadratic over an exponential function. Exponentials are always going to grow more rapidly as x approaches infinity. So just keep that in mind. We don't always need L'Hopital's rule, but we're going to see that we do need it in these next examples. So let's go ahead and push on. These are very good questions. So if I plug in and I'm trying to find this limit, this is going to happen on the test day. The limit as x approaches 3, 1, 2, 3. Okay, there it is. And I'm getting the limit as x approaches 3 of f of x. Well, we can see that that's equaling 0. And the limit as x approaches 3 of x squared minus 9 also equals 0. So this is a perfect example of when we should be applying L'Hopital's rule. And this is how it's going to be tested in May. So the limit as x approaches 3 of the derivative of f of x, which is f prime of x, over 2x. Now let's look at what happens from this. So as x approaches 3, what is f prime of x? Well, that's going down 2 over 1. So that's negative 2 over 2 times 3. So that becomes negative 1/3, right? We can see that applying L'Hopital's rule lets us find these limits of these function notation questions where we couldn't before, where we couldn't algebraically do any of this work. Okay, so let's look at one with the table. Okay, we know these are differentiable functions. We know the limit as x approaches 2 of f of x minus 4. So f of 2 is going to be 4. 4 minus 4 is 0. And in my denominator, the limit as x approaches 2 of g of x times x squared is also going to get me. So g of x is 0. So 0 times 4 is going to be 0. All right, so let's apply L'Hopital's rule. So the limit as x approaches 2, the derivative of the numerator is going to be f prime of x. And the derivative of the denominator will need a quotient rule. no, sorry, not a quotient rule, a product rule. So the derivative of the first is g prime. Hold on to the second plus the first times the derivative of the second. Now let's look what happens when we plug in 2. So f prime of 2 is going to get us -2. G prime of 2 is 3 times 4 plus g of 2 is 0 times 4. So I get -2 over 12, which is -1 over 6. And so we can kind of simplify this. And remember, we're applying all of our rules now, but we're putting it in this lens of determining a limit. And that is what L'Hopital's rule allows us to do. Apply our knowledge of derivatives to limits. And this was a great question back from 2018. We have this function, e to the x cosine x. And we want to figure out the value as x approaches pi over 2 of f over g, or state that it doesn't exist. And this was a very tough question in 2018. But now that you guys know it, we can definitely apply our knowledge to this type of question. So first, let's see if we can apply L'Hopital's rule. Let's just go willy-nilly and apply the limit as x approaches pi over 2 of f of x. Well, f of x is going to be e to the pi over 2 times cosine of pi over 2. Well, cosine of pi over 2 is 0, so that's going to get me 0. And let's find the limit as x approaches pi over 2 of g of x, which is my denominator. And we know that g of pi over 2 is going to equal 0. So there we go. And since this is a differentiable function, we know that this function was continuous at pi over 2. Okay, so we know that the limit is also going to equal 0. We don't have a weird jump or anything happening. Okay, so now that we know we can apply L'Hopital's rule, let's find the limit as x approaches pi over 2 of the derivative of f of x. Well, we would need a product rule here. So the derivative of the first is e to the x, right? Because I have e to the x cosine x, and times cosine x plus the first times the derivative of the second. So that's going to be negative sine x all over g prime, which is g prime of x. Okay, now let's apply our limits here. Okay, so we get e to the pi over 2 cosine of pi over 2. Well, cosine of pi over 2, right, is going to be 0. So that one doesn't even matter. So I'm going to get negative sine of pi over 2. Pi over 2 is negative pi. Sine of pi over 2 is 1. So I get negative e to the pi over 2 in my numerator. And in my denominator, I'm looking for g prime of pi over 2, which is right here. And since this is the graph of g prime, the y value is going to be 2. So my answer to this question is just this, negative e to the pi over 2 over 2. And we're able to discern this because we've applied L'Hopital's rule appropriately. We had to show, of course, that the limit of the numerator and the limit of the denominator were both 0, so that we had an indeterminate form. And now we applied L'Hopital's rule. Do not just apply L'Hopital's rule without showing that you can apply it. That is going to be the big thing I'm going to leave y'all with. You do have to show that the numerator is 0 and the denominator is 0. If you do not do that, you cannot apply L'Hopital's rule and you will get points deducted for that. Okay, so just keep that in mind. Of course, if you have any questions on this or if you're working through the problems, it is a really good scavenger hunt circuit for you to get through. So all the answers are going to be there for you to kind of track and hunt down. If you do need any help, please reach out to me. I'm Mr. Hernandez. This was Mr. Hernandez Teaches.